TK the Science Guy.
TK the Science Guy.
TK the Science Guy.
Apes rule.
TK the Science Guy.
Wind power. I'm a big fan. Todd. TK the Science Guy.
TK the Science Guy.
Hey CW Bio, this is Mr. Kennedy, and today I'm going to walk you through an experiment on diffusion and osmosis using a really special piece of equipment called dialysis tubing. It will mimic the behavior of a cell, even though it's not alive. I think that's pretty cool. You can find the handout for this particular lab in the cell transport section on my webpage. As you start clicking through those PDFs, this is what you're looking for. Once you have that document and you start reading through it, you're going to notice there's 3 different sections to the document talking about 3 different experiments. We're only going to focus and deal with the very first section, so you can ignore the other 2 parts. At the end of the day though, remember, you're going to write this up and it's going to become part of your science notebook for the class. So make sure you're watching, listening, and recording everything that you see. The first thing that I'm going to do is walk you through the general setup by showing you all of the equipment that we're going to need in order to pull this off. Some of the things that we're going to need include dialysis tubing. I don't know how well you can see this, but it almost looks like Scotch tape. This is what's going to mimic a cell membrane in fact. It doesn't look like much yet, but once we rehydrate it, that's when you'll see the magic. We're also going to need 2 pieces of string, and we'll use that to tie off the ends of the dialysis tubing. We have to have something to put in the tubing, so I've got a couple of things here. Some cornstarch and some regular old table sugar. Once I have things all set up, I'll show you what it looks like. I'm going to fast forward a little bit, skipping some of the boring things like taking this plastic tubing, twisting the ends like a piece of candy, and tying some string around it, and then soaking it in water. Bingo, this is what we made, right? This came from this. This is going to mimic the behavior of a cell. So basically, this dialysis tubing, well, it's not alive, but it's going to act like a cell because the dialysis tubing has super tiny holes in it that will basically let some things through but not others, the same way your cell membrane does. So inside the dialysis tubing, you'll notice that it's all white. That's the mixture that I made of cornstarch and fine granulated sugar. So once mixed, it comes out white. Now as we go to set this experiment up and to start collecting data, much of what we're going to look at is observational data, but some of it actually requires some numbers. So the next thing I'm going to do is I'm going to weigh this for you, and I'm going to show you how much it weighs as we start the experiment. All right, here we go. I'm going to put this on the scale. There you have it, 7.73 grams before the experiment starts. Back in the lab, we're going to put our simulated cell into a beaker full of water and an indicator solution that you need to know as potassium iodide, or basically iodine. So I'm going to put it in here, and I'm going to add some water. And lastly, the potassium iodide of science. I'll see you in about an hour for the results. Now, back in the lab, our beaker and dialysis bag of science appears to be ready. Now remember, as we're doing this lab report, it's very important for you to watch and listen and use everything that you see and hear to interpret what's going on in this beaker. So before I do anything else, I'm gonna review what's in the beaker so that you can draw it in your notebook. The beaker itself has a mixture of water and our indicator solution of science, potassium iodide, also known as iodide. That's why it's yellow. The dialysis bag inside, right here, has a combination of sugar, starch, and water in it. Since the sugar and starch are mixed with water, well, there's less room for water in the bag. The sugar and starch are taking up space. That should help you determine what kind of osmotic environment is inside the bag versus outside the bag. As you're making your diagrams, you're gonna wanna list everything I just described. Water and potassium iodide, iodine, the indicator of science, on the outside, and in the bag, a mixture of sugar and starch and water. Now, as you look closely, this bag looks a lot different than it did when we started. It's starting to change color and take on almost a deep purple to a black hue. The reason for that is because when iodine comes in contact with starch, it turns black. Well, at least dark purple. That should help you interpret what happened inside the dialysis bag and what's going on with regard to diffusion and osmosis. We're going to do another test to help determine or record some more data with regard to diffusion and osmosis back to the scale. The scale of science. So, if diffusion and osmosis has occurred, I wonder if the bag, the dialysis bag, might change weight. I mean, after all, it looks different than when we started. Let's see what happens. Look at that. In just a short time period, it's gained weight. That's weird. So, ladies and gentlemen, that is the diffusion and osmosis lab. What I've set up for you here is a simulated cell filled with water, sugar, and starch, and I put it in a beaker filled with the indicator of science, iodine. We weighed it before and after, and we've noted a color change in the bag. Those facts should help you interpret what's going on with regard to diffusion and osmosis. So in your lab report, what I'd like you to do is to have that before drawing that we talked about with the beaker, the iodine, the bag, all of that in it, and some arrows now to label where things moved. So where did the iodine go? Where did the water go? Why did this bag gain weight? Why did it turn purple? Okay, that should be in your notebook. Once you have that done, okay, you're gonna turn in your lab handout to the very back where you start to see some questions, right, about what you saw. Those conclusion questions should go in your lab report after your diagram. All right, ladies and gents, that's the Diffusion Osmosis Lab. This is Mr. Kennedy. I will see you next time.
TK the Science Guy.
TK the Science Guy.
TK the Science Guy.
Apes rule.
TK the Science Guy.
Wind power. I'm a big fan. TK the Science Guy.
TK the Science Guy.